Kirkwood Math. Hello and welcome back. We are moving on up. Module 4, but we're starting to go from linear equations to linear inequalities. We are going to be using pages 88 and 89 in your student companion, so let's get started. So you should understand what an inequality is. So as a reminder, it's a equation that has one of these inequality symbols, meaning it's not equal to, it's either greater than or equal to, less than or equal to. But in the past, when we've solved these, we've kind of solved them just with one variable, where you might have y is less than or equal to 2 minus 1. But now we have two variables. So let's take a look at what this solution is going to look like. So a reminder, anything that is highlighted would be a really good thing. It means it's important to write down as a vocabulary word in the margin of your notes. So the inequality y is less than or equal to x minus 1 is an example of a linear inequality in two variables. It has the same form as a linear equation, but it uses the inequality symbol. The solution of a linear inequality in two variables is all ordered pairs that make the inequality true. So any ordered pair, any point on a graph that would be true, if I put the x and the y in for that point and this would be true, that's the solution. But that's a lot of answers. So we can't just say it's this one answer. We have to actually use a graph to adequately show all of the possible solutions that are true. So when y equals x minus 1, you would have this line right here. The y value of every point on the blue ray is less than or equal to x minus 1. So all of the points on this line are true for this equation. But because we want y to be less than or equal to, all of the points that are on the line or below, all of these points are true for y. Okay, so it says now imagine drawing a blue ray for every x value. So that's just drawing that line straight down for every single number on that line, which is kind of what I already did when I highlighted. So it ends up looking like this. When all the blue rays together are put together, they form the shaded region. The solution of the inequality is all points on the line, called a boundary line, along with the shaded region. So we're going to use this word, boundary line, often. So I would write that down. The boundary line is just this line here that shows the boundary of that shaded spot, right? Our shaded spot is below this line, equal to or below this line. It's not above. Okay. We're going to do some more examples because I know that it can get kind of confusing. But again, if you look at the difference between this first line, right? This is what we've been doing, is just linear equations. All the points on the line are true. This last version, all the points on the line and everything below the line is true. Okay, let's try some more examples. Okay, so now we have another one. Y is greater than x minus 1. So because we have a greater than symbol and not greater than or equal to, we're going to use a dotted line. Think it's very similar to when we had inequalities and we would use an open circle for all greater than and less than symbols, less than and greater than, and a closed dot for all less than or equal to and greater than or equal to symbols. It's kind of the same thing. Now, all of our less than and greater than symbols are going to have dotted lines, dashed, and all of our ones that are also equal to will have a solid line because we're including all of the points, okay? So you can see here that in order to solve this, it's very similar to solving it from the last equation. For each x, find all the values of y that are greater than x minus 1. So since the inequality uses greater than, we're going to shade the above line. Greater than means shade above. And then the boundary line is now dashed because we are not equal to the line. Okay, so the solution of the inequality is all the points that are in the shaded region. This point works, this point works, this point works, this point works. All the points in the shaded region are solutions to this inequality. Okay, so here we have two inequalities, and we're going to describe the graph of these solutions, okay? So you would graph them the same way you would graph a equality. So just graph the line part, but then you need to know, is it a dotted line? Is it a solid line? Is it greater than or equal to? I believe you have graph paper or little grids on your notebook. So if you do, you can just easily graph the line and then go ahead and give it a dotted line or a solid line and shade above or below. If you do not have that on here, then you can sketch out a graph or just describe in words, right? It's going to be a line. Is it solid or dotted? Is it above or below? Okay, in this one, we're taking a real world problem and we're going to go ahead and write the inequality and then graph it. So we have the Science Club is selling t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? So the first thing we have to do is write an equation based upon the image here. So they are selling t-shirts for $10 each and keychains for $2 each, and they need to get to $500 or more because it says meet or exceed. Our inequality is going to be greater than or equal to. So here's our formula. We've got $10 times the number of t-shirts sold plus $2 times the number of keychains sold is greater than or equal to 500. We're now going to solve this by graphing. So the first thing you have to do, this is in standard form, and so in order to graph it would be easier to put it into y-intercept or slope-intercept form, or at least a version of it. I know this isn't exactly standard because standard doesn't have inequalities, but it's that same kind of format. So here we're going to solve for y so that we have a y-intercept of 250 and a slope of -5, so going down 5 over 1. They have their line. This right here, we graphed a solid line because it is greater than or equal to, solid line, and we shaded above the line because it is greater than. If my inequality here was less than or equal to, then I would shade below the line. So the inequality is telling us what line to graph and where to shade. Okay. What does this mean? It means that every point that's up here in the shaded area, okay, every point is a solution to this problem, okay? If I were to sell 0 of the t-shirts, I would have to sell 250 keychains to make my goal, or I could sell more to exceed. If I sell 0 t-shirts, I would have to, or no, keychains, I would have to sell 50 t-shirts or more to make or exceed my goal. All right, your job now is to interpret the graph that was already made. So here's our graph again. And the question is, will the Science Club meet their goal if they sell 30 t-shirts and 90 keychains? Explain in terms of the graph of the inequality. Remember that X represents the number of t-shirts sold and Y represents the number of keychains. So down here, these are our t-shirts and these are our keychains. If I sell 30 t-shirts and 90 keychains, am I going to meet my goal? All right, in your next example, we now have to go the other way. So let's take a look at this graph right here and see if we can write the equation for this inequality. So the first thing you have to do is that boundary line is super duper important. So your very first step here is determine the boundary line, the equation of this line. Okay, that should be fairly simple. We've done that before. Can you find the y-intercept? Can you find the slope of this line? Okay, so the equation of the boundary line is y equals x minus 3. That is going to tell me what the main part of my inequality is. The next thing that we have to look at is going to be where is it shaded and what type of boundary line are we using. That will tell me what kind of inequality I'm using and if it's greater than or less than. So because the graph is shaded above the line, we're going to be using a greater than sign. okay? Because my boundary is solid, I'm going to be using a greater than or equal to sign. So we're going to take this boundary line equation and we're just going to substitute in my inequality symbol, making sure that y is greater than or equal to, and you have your equation, your inequality. So give it a try yourself. Remember, your first step is to find the equation of the boundary line. Second step is then to identify, is it going to be greater than, less than, or greater than or equal to, or less than or equal to, depending on the line. And then look at where the graph is shaded. That will tell you if it's going to be a greater than or a less than inequality. All right, so we've been really focusing on graphing inequalities with two variables, but sometimes we have to graph inequalities that only have one variable, kind of back to what we used to do. Okay, so let's take a look. So if my equation is just x is greater than or equal to 3, we've graphed them before on just a number line like this, right? We have a closed dot because it's including the x, and it is greater than, so it's going to the right. But we need to put this on a coordinate plane, not just a single number line, we need a double number line. So we could write x is greater than or equal to 3 as x plus 0, okay? So that means that y is actually greater than or equal to 3. Oh no, sorry, x times 0 times y is greater than or equal to 3. So the inequality is true for all y whenever x is greater than 3. So the graph shows a little bit better explanation here. So what they're saying is this, let me show you here, this inequality, okay, is basically the same thing as graphing a line on a coordinate plane, because we're basically just have no y value, okay? There's also no y-intercept. So what it means is that here's how you would graph it, because basically x is equal to 3, okay? So all of my line's going to be on the 3. And because it's x, it's going vertically. To shade it, I'm going to then shade greater, because all of the x's that are greater than 3 or equal to is going to be a solution for this, okay? So to imagine why this happens, it says, imagine stacking copies of the solution on the number line on top of each other, one for each y value, okay, and then combining them on here to make this shaded area. It's just showing you what to do if your graph isn't completely in the standard form of inequalities or the slope-intercept kind of form of inequalities. What if I just have one variable? Well, you're going to either graph a vertical line or a horizontal line, and then you're shading, and it's either going to be dotted or solid, and then you're shading either above and below or right or left, okay? Okay, here's another example. We have y is less than 2. If I was using just a vertical number line, I would do an open dot and graph everything below 2. What I'm going to do on a coordinate plane is at y, I'm going to graph a line horizontally at 2. It's dotted because it is not equal to 2. And because it is less than 2, I'm going to shade everything below. All right, so you're going to go ahead and graph your own inequality with one variable. This is your equation here. So you have a couple options. You can cut and paste graph paper into your student companion, because I do not think they provide you a graph. You can try to hand draw it, but that doesn't always get us a very accurate result. Or if you wanted to go online to Desmos, you can see down here, this tool, it's also on Envision. But this tool is powered by Desmos. You could go to Desmos and use their graphing tool, and then you can use this thing right here. You can easily graph your points. You can change solid to dashed line and shade above and below. So you're going to do that for this problem here, and you're going to do it for this problem here, and then we're done, and I will check in with you the next time I see you.